Morning everyone once more. So if I'm audible enough, can you just do a reaction? Okay, all right. Thank you very much. Okay, all right. So our mentor is already on the call. Um,
Hi, everyone. Nice to have
yeah,
you here.
good morning, Santiago.
Good morning, George.
Yeah,
Thanks for
how is Argentina this morning?
Early morning, but everything is great. Yeah, nice weather here in Argentina.
Okay, appreciate it. That's very nice. So the students are very pumped up to have you. Like I told you the other time, we've been really anticipating the class, and because of time, so we'll be starting off immediately. So a brief intro of Santiago. Santiago is a global advocate at Wix, and we'll be taking notes on Web3 integration to front end. So I would encourage everyone to be very attentive, try to follow through. And in case of any question during the section, please feel free to just drop it on the comment section or just indicate. All right. So over to you, Santiago. It's your class. So yeah.
Right. Thank you, George. So I want to ask everyone the idea that I have for today, in case that you want to follow that, if you have any suggestion or whatever. But what I was thinking, and also speaking to George, is that the idea of today will be to kind of create your first your first DApp. So we are going to write a smart contract. We are going to create a front end for the smart contract and then integrate front ends like the React app to the smart contract. And then if you are able to master this, to manage this integration, you will be able to interact with any smart contract. So I think that's something like really valuable. Okay, I see your reactions. I guess you like that. Or do you guys have any specific idea? What I was thinking for the smart contract is to write a buy me a coffee smart contract. Who is not familiar with this buy me a coffee concept? Okay, perfect. So this, oh yeah, I see the reaction. The buy me a coffee contract is basically a contract that will receive donations, right? And then the owner of the smart contract, in this case, let's say it will be me, I will be able to withdraw these donations. So what do you guys think about this idea for today? Please give me some reactions, or say something, or send me a message, or do something. Okay, you're doing great. Thank you. Okay, perfect. So then let's start with that. I guess you're already familiar with Solidity, with some things of Remix ID. Okay, perfect. Okay, I love when you guys express your feelings, when you express your emotion. Thank you, Oche and Chuku. Okay, so then let me just share my briefs a little bit on Web3. Okay, so I have a question, Momodu. What have you done so far? Are you able to put your mic on and tell me what have you done during this bootcamp?
Thank you very much. I'm a product designer. I know HTML, CSS, Bootstrap, React, Bootstrap to an extent, and I hear about Web3 a lot, Solidity and the likes, but I've never ventured into it, and I'm looking at how I can key into Web3 as a product designer. That's why I'm here.
Okay, that's a specific niche. That's great. Okay, Solidity is new to you. Okay, so my main, DK, do you want to say something? Oh, I think what I'm saying. What I want to do today is something that all of you are able to follow. Are all of you in a computer, using a computer and coding, just to know if you are following, or you will just check the recording later? Yeah, George.
Yeah, Santiago, most of them just know React because that's where the stop at. That's really so they've not gone beyond React. So most of them on this call, Web3 is basically a new concept to them.
Okay, perfect. With React is good. That's the main thing that we are going to do today, and then some Solidity. So I will make sure to go really, really slow with the Solidity part. I will stop sometimes. If you guys have any question, feel free to raise your hand. So I will stop or just repeat too. So let me just start by sharing my screen. Okay, I'm sharing now. Yeah. Okay, so the first thing that I want you to do is to go to remix.ethereum.org. Then once you are here, you will see all these different things. Are you guys already familiar with Remix, or you didn't see Remix at all during the course? Ooh, okay, I see that crying face. That you haven't. Okay, perfect. Okay, perfect. So then you will learn something new today. So please go to remix.ethereum.org. That's fine. I'm not expecting you to know things. The less that you know, the more that you will learn today. So it will be fine. Yeah. Oh, yeah. That was the link. Thank you, Eva. Perfect. So then once you are in remix.ethereum.org, you will see this, like this kind of folders here, states, contract, scripts, test. We are going to use Remix to write our smart contract. So the first thing that we need to do is to create a file for the smart contract, because from Remix, we are going to deploy the contract to the Ethereum testnet. So that's important to know. If you guys get lost, please stop me so I repeat instead of waiting for me to do the whole thing. Okay. So I'm really happy if you interrupt me. So don't feel shy. So the first thing that I'm going to do is here in this contracts folder, I will create a new file. So as you can see, I just open the contracts, then I click here and create a new file. It's blank. I'm sharing my whole screen. Do you guys can see the screen or not? Hopefully I'm sharing. Oh yeah, everyone is able to see my screen moment. Maybe try to refresh the page or something. Okay, perfect. And then let's create a new file. So the file, I will call it pytech.sol. This will be the contract that we are going to write today. So basically now this is the smart contract, right? But it's empty. And here we are going to write the code of a smart contract. Normally we always have a structure for smart contracts. And first you need to put the license. Yeah, DK, have a question?
Yes, I do have a question.
Yeah, tell me. It's fine. You can interrupt me. We have a lot of time today, so
Okay,
it's okay.
do you have do you need to have like an idea about coding and the rest for you to be able to run Web3 perfectly?
Like if you need to know coding to be able to join Web3, or what's the question?
Yeah, to be able to solve through the Web3 perfectly, do you need coding?
No, not really. You don't even need to know coding. I mean, I guess yeah, today the session is coding related, but you don't really need coding to be able to join Web3 or to interact with contracts or having a wallet and things like that.
Okay, thank you about that.
Perfect. Yeah, this is only to, if you want to deploy applications to Ethereum to Web3, then you will need coding. Yeah, Isa?
Sorry to ask. Sorry to ask, sir. So what's Web3 all about?
What is what? I didn't hear you.
I am
Sorry.
What's Web3 all about?
What is Web3 all about?
Web3. Yes.
Okay, so to answer that question, I would say Web3 is about decentralization and transparency. So the whole point that we are going to do today with this smart contract is we are going to deploy the contract, and the contract is like a piece of code, right? Once you deploy this piece of code to Web3, to Ethereum, no one can change this piece of code, and everyone can see who is interacting with this code. So the beauty of Web3 is that that's decentralized and immutable, because no one can change this once you deploy the application, right? While, for example, if you are using Web2 applications like Facebook, the servers can change, let's say, your name or your age or whatever. So the whole point of Web3 is that no one can really change the data because it's something immutable and everyone can see the data too. So that's like the main, let's say, competitive advantage of Ethereum. Okay, so I will continue here with it. Perfect. For the smart contract, what we need to do is first write this line of code that it just says SPDX license. I forgot the other one, license identifier. Yeah. So the first line, we need to specify the license of the smart contract. I'm not really like a license expert, so I will just always use MIT. That doesn't really matter. That doesn't really change the contract at all. Zoom in. Yeah. Can you see better now? Perfect. Okay. So the first line, SPDX dash license dash identifier. Then we put MIT, or there are also another ones, but yeah, we don't need to dive into that. Then in the second line, we need to specify the Solidity compiler of the smart contract. This is just specifying the version of the smart contract that we are writing. Like when you are writing in JavaScript or TypeScript, you need to specify the version of JavaScript that you're using. So it's the same thing here with Solidity. And then after that, you need to write the keyword contract, then the name of the contract. I will call it high-tech. And then you just open the curly braces. So this is basically the initial structure of the smart contract, the license, the Solidity compiler, 0.8.0. You can also see other different versions. The latest is 0.8.28, but I will just use 0.8.0. And then the contract object. And here we are going to write our contract inside these curly braces. Is this clear so far? Okay, that's great. Thanks for the reaction. I appreciate that. Okay, so for the smart contracts, what we need to do, first, we need to say what are the state variables of our contract. Remember that in this contract, we are going to have a contract that will receive the funds. So let me just write that here so it's easier to understand. That will receive funds. Those funds will be Ethereum. The owner of the contract, so let's say in this case, Santiago, will be able to withdraw the funds. But let's specify only Santiago, because we don't want that people can send donations to this contract, but then George can come and withdraw my donations, right? So that's why we need to specify that only Santiago can withdraw these donations. And yeah, that's basically what we are going to do today. So it will be something simple that you will be able to follow as well. So the structure of a smart contract, normally we always have state variables. These are just comments. You don't need to put these comments, but it's just to give you an idea. We have a constructor as well. And then the most important concept that I want you to learn today is that in blockchain, all the smart contracts only have two functions: writing functions and reading functions. So basically, the only two actions that you can do with the blockchain is calling writing functions and calling reading functions. So the reading functions will kind of return information. So this is like a read-only function. You don't need no wallet needed. You don't need wallet, you don't need funds, you don't need anything to interact with these reading functions, because you are just reading something from the blockchain. So that's free, right? But then the writing functions will update the state of the contract. I'm going to show you this in a few seconds. But then what happened with the writing functions is that you are editing something. Maybe you are removing a balance, or maybe you are updating a balance, or or whatever, but you are changing data, right? So that's why it's called writing functions. And for these writing functions, wallet needed. So you need a wallet because you will need funds. Because when we are interacting with writing functions, you're sending a transaction, and sending a transaction means that you're spending some funds, right? So the main thing and the main outcome that you will see today when we talk about React, like when we jump into React, it will be easier for you to understand this. We only have two functions, writing functions and reading functions. Simple. Any question regarding these comments, guys? Okay, thanks for the reactions. I appreciate that, David, Jethro, Fatima. Chuku. Oh, and where was Momo? Were you able to see my screen now? I don't know where are you. Momo, yeah. Momo, are you able to see my screen now? It's fine. Perfect. Let's see. Okay, I don't know why. But yeah, okay, at least you are able to see it. So in this contract, we are going to have only one state variable. This state variable will be an address that will store who is the owner of this contract. So remember that is there a link to recording? Yeah, it will be a link to the recording later. So yeah, don't worry about that. And I will also publish this in the GitHub repo, so you will be able to see the code too when everything is working at the end in 2 hours. So in this smart contract, you're welcome, Momo. We are going to have this owner here. This owner, let's say that it will be Santiago's address, because I only want Santiago's address to be able to withdraw these funds, right? Okay, and now we are going to implement 3 functions. So the first function that we need to write is a donate function, because this function will receive money, right? The whole idea is that when we call the donate function, the contract will be able to receive the donations. So we are going to call a function donate. Did you already? I don't think you did. You kind of saw Solidity, but I don't know if you were able to write this before, or is the first time that you see these functions in Solidity? Okay, perfect. Thank you, Chuku. Okay, thank you, David. Okay, so in Solidity, we are going to have these 2 functions, writing and reading. We always have this kind of keyword, sorry, that it can be public or external. For now, I don't want to really dive into that, so don't confuse you, but you can always use public. That would be just easier to understand. So this is how you write a function in Solidity: the keyword function, then the name, in this case will be donate, and then the keyword public. This public is kind of allowing everyone in the blockchain to interact with this function. Because if you put, for example, internal, people cannot really interact with this function. So yeah, let's leave it public. Then we are going to have another function that we'll call it withdraw. So this, let me put the comment here. This function will receive ETH, the donations. This function will withdraw the donations to Santiago, because I'm the owner of the contract. But in your case, you will be the owner of the contract too. Okay, so far we have these 2 functions, and then another function that I will call balance. This balance will be able to tell us what is the current balance of the contract. So for these reading functions, you need to have the keyword public, but then you also need to specify that this is a view function, and then you need to specify which value or which variable is returning this. So in this case, this will return a U into 56 because the balance will be a U into 56. A U into 56 is just like a number. So you can, guys, see the difference. When we are writing functions, we only need to put public here. But then when we are writing reading functions, we need to specify that it's a view function and the value that is returning. Is that clear so far? I can repeat whatever that you need. Okay, thank you, Fatima. Thank you, David and Habib. Okay, perfect. That's great to see the reactions. Amazing. So remember, we only have writing functions, reading functions. In this case, the donate function will receive ETH. The withdraw functions will send the funds from the contract to Santiago. And then the balance function will just return or show the current balance of the contract. So every time that someone make a donation, this balance will be updated. Perfect. So now let's jump into the implementation of these functions. And let me do the constructor too. Do you guys know what is a constructor? Any reactions for constructor? You know, you don't know? Just say something. Okay, you know. Okay, perfect. So Emerson Rufai Chukwu, a constructor is one function that will be only executed for one time, the time that you deploy the contract to the blockchain. So when we deploy this code that we are writing here to Ethereum, this constructor will be executed in the deployment process, and then this constructor cannot be called again, like anymore. This is only a one-off function. So what we want to do in this constructor is to specify who will be the owner of the smart contract. So in this case, I will be the owner of the smart contract. And because I will interact with this wallet here that you see here, I can hard code the wallet like that. And then what I am doing is that I'm specifying that this wallet, that is my wallet, is the owner of the contract. This is important because then when we call the withdraw function, we want that only this address is able to withdraw the funds, right? We don't want that George come here and withdraw the funds of my contract. So in this case, I will copy paste the wallet, but you can also use something that is called message.sender. You will see this when you dive more into Solidity, and this message.sender is the address that is deploying the contract. And deploying the contract is just putting the contract into the blockchain, and it will be the same message.sender than just putting my wallet here too. It's basically the same result. Oh, Isa, what are we developing? We are developing a smart contract that will receive funds, and then we are able to withdraw these funds. Something like that. I don't know if that's kind of clear. I can dive more into the logic of that, but yeah, there's a contract that will receive money, and only Santiago will be able to withdraw this money. Is that clear, Isa? Yeah. It's like a web app, but then the smart contract, let's say, is the back end, and then we are going to work in the front end after we make this back end. Yeah. Is that clear, Isa? Okay, perfect. Yeah, so in Web3, we can call the backend like the smart contracts, and then the front end will be React. As you already know React, it will be easy for you when we start working on the React part. But yeah, right now we are just working in the backend of the application. That is this smart contract. So far what I have done is just implemented the constructor. The constructor is when we deploy our backend, the owner of this contract will be this address. So what we want to do now for this donate function is that we want to allow the users to send funds here. So what we can do is we need to use some keywords here, and it will be address this transfer. So what we are doing here, let me just, oh yeah, I need to put this payable. Payable. Okay, so now here I introduce a new keyword that is called payable. This payable needs to be here because this function will receive funds, right? And every time that a function will receive funds, we need to use the keyword payable. So you can see public payable here. And then what we are doing here in this line of code is address this is the address of this smart contract. Then dot transfer is transferring right here. Is transferring the funds to this smart contract. And then message.value is kind of taking the ETH that is being sent by the user. So yeah, I'm trying to just break down everything line by line so you guys are able to follow. Do you have any question with this line 21 of code? I know there is like a lot of parentheses and keywords, but yeah, I think with this it's easier to understand a little bit. We're just basically sending money to this address. That's why we are using the transfer. The message.value is just getting the value, or in this case, the funds that are being sent. And we just need to use the keyword payable to be able to send the funds. So just like that, people will be able to interact with this function. And I'm going to show you that right now too. Yeah, Chuku?
Okay, so can you hear me?
Yeah, I can.
Okay, this keyword you use in the donate function, is the kind of is this referring to the constructor wallet that you declare at the top, the constructor address? Because I'm a little bit confused. In
Okay,
this
wait,
line, you are referring to payable that addressed this. So I'm kind of confused on that this you put.
Okay. Okay, so I will give you, I know how to answer that question. So I will just, this is just to explain, to answer that question, but you don't need to write this, guys, but I will just write this: send funds to this contract and send funds to, let's say, Santiago. Let's say Santiago. So if you want to send funds to this contract, you need to write this: payable address this dot transfer dot message dot value, right? This is what I already wrote here. We are sending funds to this contract. But then if we want to send funds to Santiago, we need to write this payable address. And then instead of this, we can put this wallet here. Let me just, I hear some echo from you, Chuku. Can you mute purpose? Thank you. This and then dot transfer and then message dot value. So the main difference is that the keyword this is sending the funds to this FiTech contract, right? Because our contract will be able to receive funds. But then in this another example, we are sending funds to this FE90 address, which is my address, right? So that's the difference. This keyword is interacting with this contract in this context. And then here I'm just hard coding a different wallet address. Does that solve your question?
Yes, I understand now, sir.
Perfect. Amazing. Thank you. Okay, so what we are doing here, this is only one line of code that we need to write in the donate function to send funds to this address. Then for the withdraw function, what we need to do is instead of sending the funds to this, we need to send the funds to the owner, right? So let me write the code and then I'm going to write the comments. So payable address I think we can put directly owner here. Transfer message dot value. And then, okay. Payable. Okay. This one has to have the keyword payable because we are sending funds to here. Oche. Okay. What you say? Wow. Is it good? You are learning something new, Oche? Okay. Amazing. So in the withdraw function, instead of sending the funds to the contract, we are sending the funds to Santiago, right? So now you can see that instead of address this, I'm just putting owner. Because if we check who is the owner is this address, right? So it's like the same of putting this address here. And then we are using the same keyword transfer. And then instead of message.value, what we need to use is the balance of the contract, because we want to be able to send the total balance of the contract. So let's say current balance of this contract, just being really explicit with the variables. And then to be able to get this current balance, so we can use this u into 56, current balance of this contract equals to balance. What we are doing here is that we are going to call this balance function that we haven't implemented yet, just to get the current balance of this contract. And then when we transfer the funds to Santiago, we are transferring all the current balance of this contract. Is that clear, guys? Okay, that's great. Thanks for all the reactions. Appreciate that. Perfect. And then we just need to implement, let me just put some comments here. This is fetching the current balance of the contract. And this is sending the funds owner. Amazing, Rufai. I love to read that. So I'm doing a good job of explaining that in a really easy way. Yeah, I think Solidity is just about repetition and you will be able to get everything. But yeah, it's pretty simple what we are doing today, and it's really good because we are using some advanced topics like payable and transferring funds. That's like a little bit more advanced. But yeah, we will be able to manage everything. So yeah, this is sending the total funds to owner, current balance of this contract. Actually, that's really pretty easy to understand. The current balance of this contract variable is fetching all the balance, right? Thank you, Isa. That's true. That's true. And then we will need to implement the balance function. So here we can just type return, and then we are using the same keyword chuku that is called address this. But now instead of using transfer, we are using balance. And basically this address this dot balance will return the total balance of this smart contract. Okay, now that I did all this code, I will use Remix to kind of show you how this works, and it will be easier to understand. So here in the left, we have two main things that you need to use in Remix. The first one is the Solidity compiler here. So when you're in Solidity compiler, I always check this auto-compile. So every time that I'm writing one line of code, this is compiling just to check that the code is correct. Otherwise, you can just click here in compile, and then you will see if it's working or not. But yeah, in this case, it's working. So you can see this green check. And then the most important one is this one that is called deploy and run transactions. So for the deploy and run transactions, we are able to deploy this smart contract to a local virtual machine. In this case, it's called Remix VM. So if I click in deploy here, this is a really important part. If you get lost, feel free to stop me, interrupt me. So I will click in deploy, and you can see, let me zoom out. You can see that when I click on deploy, I get like this green check, it means that it deploys the smart contract to Remix virtual machine. We are going to use the same, but in Ethereum testnet, and then you will see the same process. But yeah, right now I just deploy the contract to Remix virtual machine. And then here you can see deploy contracts. And then you can see that I deployed the PyTech contract. And we have these different functions: donate, withdraw, and balance. If I click in balance, right now the balance is 0, right? As you can see, balance is 0. Then if I click in donate, I need to specify here in the value. Remember that I'm still here in the same tab, deploy and run transactions. So if I come here to value, I can specify how much I want to send. So if I want to send 1 ETH, I can just put here 1. So what I'm going to do now is donating 1 Ether to the smart contract. And then let's see what's going on here. Oh yeah. So something important, I remember this. Every time that we are sending funds to a smart contract, we need to write a function. This is just by default. Like, it doesn't really make sense, but this is just by default that you need to write this. An empty function that is called receive. Let's see. Okay. So what I did here is just to write this empty function that is called receive external payable. Without this receive external payable, the contract is not able to receive funds. So as you can see, when I try to send funds here, it gives me an error here. So now that I wrote this function, we need to redeploy the smart contract in the Remix virtual machine. So I will just click here in remove the contract. Now you see that we don't have contracts in deploy contracts. And then, yeah, and then I'm going to redeploy the contract. So I just come here again and I click in deploy. Then we see that we just deploy the contract. And then if I click in balance, we still have 0. And now if I try to donate 1 Ether, let's see what happens. So I click in donate. And now you see that we got the green check. That means that we were able to donate, right? And then if I check the balance again, you can see that the balance it has 1 ETH. Do you guys know what is the difference of a WAY and ETH? These two kind of numbers here. Okay. Okay, Jetro. So these are just like measures, units in Ether, in Ethereum, to be able to see. Let me just show you here. The smallest unit in Ethereum is called a WAY. So if we check 1 Ether, when we are talking about I'm transferring 1 Ether, at the end of the day, this 1 Ether is this huge number in WAY. So 1 Ether is 10 to the power of 18 WAY. So this is just like 18 zeros, as you can see. And everything in blockchain is kind of written in WAY. When you're a developer, you always need to think in WAY, not in Ether. So that's why when I try to check the balance, we get this huge number, because this huge number, if I copy paste here, for example, you will see that it's 1 Ether. Is that clear? Okay, amazing. Thank you. So now we see that our smart contract has 1 Ether, right? And then what we need to do is let's actually donate another Ether, so you will be able to see. So if I click in donate again, let's actually donate 20. I put here the 20, and then I click in donate. And now you can see that the new balance is this huge number, 21 and then 18 zeros. Because now I donated 20 ETH, right? Is it clear so far? Amazing. Yeah, Chuku? Oh, I think you were just reacting. Yeah, perfect. And then the last function that we need to test is the withdraw. So supposedly if I click in withdraw, my balance will increase, right? So you can see that Remix is giving us some kind of wallets to interact with the contract, right? So in this case, Remix is giving you this wallet, this one, this one, this one, and you see that all of them have 100 Ether. But this one has 78 because we already donated the funds to the contract. But now if I withdraw the funds, I will be able to have 99 Ether again. So if I click in withdraw, what happened right now is that this 21 ETH that were in this contract just go to this new address here, that is the owner, because I hard-coded the address. But if I put message.sender, it will be the address that deployed the contract. So let me just kind of run this example again. So I just updated this line of code. So what we need to do is redeploy the smart contract. Every time that you write a new line, a new keyword, whatever, you need to redeploy the contract. So you come here, you remove the smart contract. You click here and deploy. Now we just redeploy the contract. And then let's say that I want to donate 50 Ether. And check that my current balance is 78. Then if I donate by clicking here, 50 Ether, now you will see that I have 28 because I donated 50, right?
So we can't see your screen.
You cannot see my screen?
Yeah, we can see it. Just zoom your screen, we can see it. Just zoom it now.
Oh, okay, perfect. Yeah, the thing is, every time that I click in a function, it kind of moves around. But yeah, I will make sure to zoom in. Okay, so here we have 28, right? Because we donated 50. So if I click in balance, now we can see that the current balance of the contract is 50 ETH, right? And then if I click in withdraw, now you can see that my balance again is 78. And then the balance of the contract. Oh, Isa, can you mute yourself, please? Perfect, thank you. And then now the balance of the contract is 0. So any question with this part? Perfect. Yeah. George, are you able to mute Isa, please? Okay, perfect. Thank you. Okay, so any question with this so far, with the contract? Now we have a contract that has 3 functions: donate, withdraw, and balance. The donate function is receiving the funds, like receiving the donations. The withdraw function is sending the funds to the owner of the contract, in this case my address, and then this reading function is just returning the current balance of the contract. Now we are going to interact with these functions from a React application, and you will see how everything works. But yeah, do you guys have any question with this? Okay, that's great. Thank you, Fatima. One thing that I want to add here in this withdraw function is I want to add like a check that only the owner can withdraw the funds. Because as I mentioned, we don't want that George come here and try to withdraw the funds of my contract. So to implement this, we can write the keyword require. And then if this condition is not true, then the transaction will revert, and then this will not be executed. So we just need to type require message.sender equal to owner. So message.sender is the person, like the wallet, that is calling this function. And then we are just double checking that the message.sender is equal to the owner. And remember that the owner, okay, I will just draw. And then the owner of this contract is the person that deployed the contract here. And then we can just put like some kind of like a string here that says you are not the owner. Just read the comment. Withdraw, donate, and balance. Okay. So Jethro, the donate function is just receiving funds with this line of code in line 21. The donate function is just allowing the users to interact with this function to donate. I will interact with this function again so you are able to see. The withdraw function is withdrawing the funds and sending these funds to the owner. And the balance is just returning the current balance of the contract just as an informational function to see what is the balance. If we want to query the balance, we just need to call this balance function. So what I'm going to do now is from this account that is C4, that ends in C4 here, I'm going to deploy the contract. So that means that the current owner is this wallet, right? The one that ends in C4. And then I'm going to change to another address like this one that ends in B2. And I will donate 99 ETH to the contract. So remember that we just need to put here the value that we want to send. I will put 99. And then I click in donate. And then if we check the balance of the contract, we can see that we have 99 ETH in this contract. And the current balance of this wallet is 0 because we send 99 ETH, right? Then I will do the same with this address, which ends in DB. And I will send 99 ETH. Click in donate. And then click in balance. And now you can see that the balance of the contract is 198 ETH, right? Okay, perfect. That's great. And then if I go to this address that ends in, let's say, AB, you can see this AB address that has 100 ETH. If I try to withdraw, you can see that it's not going through, right? And then we are getting this string that says reason provided by the contract, you are not the owner. Why? Because when we are trying to withdraw the funds, we are withdrawing the funds from a different address that is not the owner. So that's why it's reverting the transaction. And we are just getting this string with the error that I put here in line, which line is this? In line 31st. No, in line 29. Yeah. So you guys are able to see that George now is not able to withdraw the funds. But then if I change to this address, the C4, because remember that this C4 is the owner of the contract. So if I change my address to C4, and then I click in withdraw, you can see that we got the green check. And now the balance of the contract is 0. And now you can see the balance of this address. Address C4 has 276 ETH. Address B2 has 0. Address DB has 0. And this one has 99. And then the other one just have 100. Are you guys able to get this owner concept? Like the owner is just the first wallet that deployed the contract. So only that address was able to withdraw the funds. When I tried to withdraw the funds with the other address, it didn't work, right? So you guys have any question with that? Or is kind of that's before we jump into React? Yeah, Chuku?
Okay, sir. Can you hear me, sir?
Yeah. Oh, wait. Before you ask, I will just reply to this one. Akanimo, in Solidity, we don't really have like 3 checks. We only have 2 equals. So yeah, that's only in JavaScript that we use 3 equals. But yeah, here we only use 2. And then if I check the in-call message. Okay. I don't get that question, Rufai. But yeah, Chupu, tell me. Go ahead.
Okay, so does it mean that anytime you made changes in Solidity, you have to kind of redeploy it, kind of delete and redeploy it?
Yeah, you don't
something
you
like
don't
that.
I mean, in real life, let's say in Ethereum, once you deploy a contract and you want to update something, you need to deploy a new contract, but then the previous contract will not get deleted. That contract will be there forever. And then you just deploy a new one, and then you have the new one with the new code. But yeah, every time that you update something, you need to redeploy. And that's the beauty of Web3. You know why? Let's say that I have a contract that does anything, right? But then what if I update the code to do something malicious and maybe steal your funds? That's not good, right? So that's why when you are interacting with one contract, you know what is the code of that contract. And then if you want to have something malicious, you want to add something malicious, you will be able to see that this is a new contract. This is not the same contract that I trust from before. So every time that you upgrade something, you need to deploy a new contract. Yeah.
Okay, so I think I understand now. I think it's a kind of more safer. I think I understand.
Yeah, I mean, there are some ways that you can upgrade contracts, but yeah, by default, you cannot really upgrade a contract. If I have a contract that receive funds and send the funds to Santiago, that contract will be there forever. And now if we want to send the funds to other person, we need to update the contract with new code. But yeah.
Okay, so I understand now, sir.
Perfect. Amazing. Thank you. Thank you, Chuku. Thank you, Jetro Akanimo. Okay, I think that's kind of clear. So what I'm going to do now is to deploy this contract to a blockchain, like to a real blockchain, but it's called a testnet. So what I'm going to do is, instead of having Remix virtual machine, I'm going to choose injected provider. So this injected provider, let me actually disconnect this so you see what's going on. So when I click in injected provider, MetaMask is showing up here, and then you can see that it's asking me to connect my address. So in this case, I'm going to choose this account, and then I will just click connect. And now I just connected my address to Remix. That's the only thing that I've done so far. And then we are connected to Lisk Sepolia testnet. This is like a testnet of Lisk. And what we can do is that now when I click in deploy, let's see, yeah. When I click in deploy, MetaMask is popping up again. And look, that is showing all these things. That is basically, we are just deploying a contract. So now this contract is not being deployed in Remix, as I was showing you before that we were just testing Remix, but now we are deploying this to a real blockchain, that is the Lisk testnet. So when I click in confirm, you can see the creation of PyTech pending. And now it's showing this green check. So the green check means that the contract deployed successfully. And then if I open here the green check, you will see more information. And in that more information, we can see the contract address here. So this is the contract address of our smart contract. So I will just copy this. And then we can go to Lisk Sepolia Explorer. So here you can see Lisk Sepolia Testnet Blockchain Explorer. And then you see this search by address. So if I copy paste the address of this contract, we can see that we have a contract creation 55 seconds ago, 57 seconds ago, right? Because I just created this contract 1 minute ago. So you saw, guys, that basically just by changing the environment to injected provider and connecting MetaMask to Remix, now we deploy the contract to Lisk. For you, I don't know if you guys are familiar with MetaMask, but depending on the network that you have here, if you have Ethereum mainnet, Linear, Lisk, Base, Binance, Arbitrum, etc., you will deploy the contract to that network. But to deploy the contract to that network, you will need to have funds, right? In this case, I have funds in Lisk, so that's why I deploy the contract to Lisk. Let's see if there's any questions here. Perfect. So now when I come here, you can see that we deployed the contract 2 minutes ago. This is the address of the contract. And something that I always recommend to do is to verify the code of the contract. So if we come to contract, we can see that this is the bytecode of the contract. It's just like a lot of low-level code, but we can click in verify and publish here, and then it will ask us for some details. So contract license, MIT. Remember that the license was the first thing that I wrote in line number 1, MIT license. Then this is a single file because we just created like one single file in Solidity. Then the compiler version 0.8.0. This is only to verify the contract. You don't even need to verify the contract to interact with the contract, but I'm just showing you some other things that will be useful. So the Solidity compiler is 0.8.0. The EVM version, we can just leave it like that. We can uncheck this optimize enable. And then here we'll ask for the contract code. So I will just copy all of this here. And then verify and publish. And now you can see that our contract, when we search for our contract here, now the contract is showing this green check. That means that the contract is verified. And you can see that when we check the contract in the Blockchain Explorer, we see all the code here. Look at the license, the compiler, and all the code here. So that's why now that this contract is deployed here, as Shuku was asking, this is the code of this contract. And when people interact with this contract, they see this code. If I want to change something else, then we need to redeploy a new contract to verify the contract again, and then people will be able to see what is the contract that they are interacting with. So yeah, so far in this first hour, we wrote the smart contract. We deployed the smart contract to Lisk testnet. And now in the second half of this meeting, we are going to create a React app to interact with this smart contract. Do you guys have any questions so far? We just get like a little snack here. So yeah, we just deploy the contract. Let me know if you have any questions. Yeah, Chuku. Sorry guys that I'm eating.
Okay, when deploying on a testnet, you use any preferable testnet, or is there any specified one that you use for the deploying?
That's a good question. I'm using Lisk because I work for Lisk, so I'm using Lisk testnet, right? But normally I always use the Ethereum testnet, and it's basically the same. That it doesn't really matter. Just to show you something, I like to teach people things in general, not promoting Lisk, but just for you guys to be able to learn the skills. If I come to MetaMask and instead of having Lisk Sepolia, I choose Sepolia, only Sepolia testnet. And then if I click in deploy, let's see what happened here. Let me just refresh. Okay, the provider. So now, as you can see, I just changed from Lisk testnet to Sepolia. And then if I click in deploy, confirm, now we are deploying the contract to Sepolia testnet. So if we go to Sepolia Explorer, and then we check this address, contract address here. The contract is empty, right? As you can see where it is. It will take a few seconds. Okay, maybe that kind of even answer a question. The issue with Sepolia, this is the Ethereum testnet, is that it's a little bit slow. Lisk is way faster. So yeah, maybe that's a good point for Lisk. Because I deployed this contract 10 seconds ago, 20 seconds ago, and it's not showing here yet. It's supposed to show us here a contract creation transaction. But look, that is taking a while. But when I did it with Lisk, it just it shows run right away, right? So yeah, I like Lisk, but it is basically the same process, to be honest. Lisk and Sepolia is the same process. but now I'm noticing that this maybe is a bit faster. But yeah, you saw that just by changing the network here, I deployed to Lisp or I deployed to Sepolia. But yeah, being neutral doesn't change anything, but Sepolia seems a little bit more slow. Any other question, guys? Well, this is shown here.
Okay, sir, I still have a question, sir.
Oh, yeah.
Okay, sir, the question now is, can you kind of explain testnet in a term of Web2, in term of a Web2 level? Like, can you give a kind of example? Because I don't really understand what testnet is. I know that we deploy our code. Can you kind of explain it better so that I can understand?
The answer is pretty simple. The answer is funds. You're using real funds or fake funds. So what happened is when I deploy this contract to Lisp, for example, this is the fee that I pay for deploying this contract. So if we check this value in dollars, ETH to USD, we basically pay $0.0028 to deploy the contract, right? But because it's a testnet, we are able to get this for free. So in testnet, you can get ETH for free to play around. So I can send you 1 ETH now. If you give me your address, I can send you 1 ETH in the testnet, and we can play around with ETH, right? But then if I want to deploy this in the real mainnet, Ethereum, Lisk, or any mainnet, I will need to pay this for real. I will need to pay this. I missed the value. Let me just put it here. I will need to pay this $0.0028 for real. Like this needs to be real money in mainnet. So that's the main difference of the mainnet and testnet. That's for testnet, you can get it for free. And for mainnet, you cannot get it for free. No one will give you it for free. If you wonder where you can get it, you can put Lisk faucet. And then you will get like different faucets here. Like this one, for example. And then what you can do is that you will receive 0.1 Lisk testnet tokens. So I just put my address here, request, and then they will send me testnet tokens. So only like this, you're able to get testnet tokens. But for a mainnet, no one will send you real tokens, right? So that's the main difference of mainnet and testnet. Yeah. Any other question? Was clear? Yeah, Jetro.
So the mainnet and the testnet, is it just like a place where we deploy our smart contracts and then retrieve it when we want to use it? So I want to know, is it like where we store our smart contracts, or does it do more than that? Is it just basically for storage, or it has other functions?
That's a good question. I will say that analogy is true. The blockchain is like a database, and we deploy this contract to that database of Lisk testnet. So our contract is living in Lisk testnet, right? And then we need to interact with the contract. And then, for example, if we want to interact with the donate function, we will use this testnet ETH to send the donations. But in the real life, in the mainnet, we cannot send fake or testnet ETH, right? We need to send real funds. So now, right now, the contract is installed, or I will call it deployed, to Lisk testnet. And that's where the contract is living right now. Yeah. In that, let's say that in this server, in the server of Lisk testnet, basically. And then they will just help to interact with the contract there. Perfect. Any other question, guys, before we jump into React? Yeah, you're right, Momo. Okay, so what we are going to do now is create a React app. So what I'm going to do is just create a new folder that I will call PyTech. So right now this folder is empty. I just created a folder, and then I will create a React app, npx create React app, and then I will call it PyTech app. Then this will create a React app. Feel free to send messages, to ask questions or whatever while we create a React app. Clear so far? Are you guys able to react if everything is clear? Amazing. Thank you. Okay, so hopefully this works. So what I did right now is that I just created a React app. Just a second. Okay, so as you guys can see, I have a React app here. I'm just going to run this, see if this is working. Okay, I'm always getting this error here with the web vitals. So what I'm going to do is just to remove some lines of code that I don't need. So I will remove this file of report web vitals. I will remove this setup tests. And then in index, I will remove this. I will comment this here. Then where else we have that? Where is it? In source. Well, we have in source. Let's see where else we are using the web vitals. Here. Okay, so far I created an empty React app. I guess you're like you told me that you are familiar with React, so I think this is simple, right? Okay, amazing. Rufai, Habib, Chuku, Jetro, thank you. Rufai, yeah, to be really honest with you, I just started learning coding like 2 years ago, and I started right away in Web3. I have no idea about Web2. Like I never used MongoDB. I never use SQL. I don't know anything about Web2, and I just started directly in Web3. I will prefer, and it would be better if I started in the right order of learning Web2 or computer science or things like that. But yeah, I never went to university. I never learned anything Web2. Never did any coding like that, and I directly started in Web3, and I'm here teaching you guys today, right? So I don't think you really need to know about Web2 before getting into Web3. Amazing, thank you. So I guess we are in the same page now. We just have this React app. I will remove this. And we have this empty React app, right? So what I'm going to do now is create 3 buttons. One that I will call donate, one that I will call withdraw, and one that I will call balance. So every button will be interacting with every function, right, of the smart contract. When we click in donate, we are sending donation. Withdraw will withdraw the donations to Santiago, and the balance will just show the balance. To use this, what we need to do is install a Web3.js library. Like for this, before working for Lisk, I was working for Web3.js, and Web3.js is basically a JavaScript library that allows you to interact with the blockchain using JavaScript, right? So that's why we are going to use Web3.js today. To install Web3.js, we just need to type npm install Web3. And then you will see that in our package.json. That will be here soon. Yeah. So as you can see right now, I just installed Web3 4.16, npm install Web3. Any questions so far? That clear? Perfect. We'll assume that is clear so far.
Yes, sir.
Yeah, Rufai?
While you were installing your Web3.js, you didn't write the install in full. Is there like, does that mean anything or not?
We are, like, your question is why, right?
Yeah. Why didn't you write your install in full? You just wrote alone.
We need to install Web3.js because Web3.js will help us to interact with the blockchain, and that's why I just typed npm I Web3 to install the library. And yeah, we are going to use it to interact with the contract that we deploy. Oh yeah, the question is for the I. Yeah, npm install is the same than npm I Web3. This is the same. Right. Thank you, Chuku. Perfect. Yeah, exactly. Thank you, Chuku, for the explanation. So now we need to import the Web3.js library. So just type import Web3 from Web3. Simple. Here we need to put the curly braces. Something that I want you to notice, don't forget, is that this Web3 that we are importing, this module, is with the W uppercase. But the library itself is Web3 with the W lowercase. So that's why we need to put here, import the Web3 module from the Web3 library. And one is Web3, and the other one is Web3. Because I saw that mistake a lot. I've done this more than 20 times in Africa, and I already know which mistakes always happen when people are trying to do this. So yeah, I'm just kind of letting you guys know so you don't make the same mistakes. Okay, then after this, we need to initialize the Web3 object. So we need to type const Web3, or you can name this in any way that you want. Maybe let's call it Web3 PyTech for today. And then we just need to type new Web3. So we are kind of initializing this module from here. We open the parentheses, and then inside the parentheses, we put window.ethereum. This window.ethereum is an object that we have in the browser that will allow us to interact with the blockchain from the browser. So you will see that. Any questions so far? I just wrote two lines of code. Line number 3, import the library. Line number 8, initialize the library with the window.ethereum keyword. Is that clear so far? Perfect. Thank you. I'm going really slow and stopping and things like that, so you don't get lost. So after we initialize the Web3 object, we can initialize the contract. So we can just type, let's say, my contract, any name. Yeah, my contract, and then new, and then we are going to use this keyword a lot. New Web3 PyTech dot ETH dot contract. So look that we are going to use this keyword here a lot. So that's why I just put Web3 PyTech, so you kind of remember that we are using that. This contract will accept two things, an ABI and an address. So the ABI is just kind of a translation of the bytecode of the contract for JavaScript. So maybe we are wondering, where the hell can we get the ABI of the contract? So we go back to Remix. We go back to Solidity compiler. And then when we scroll down, we see ABI here. And then I'm going to show you what is the ABI. So I will just create this cons ABI equal to this. So the ABI is just this JSON object that is translating all the functions of the contract into this JSON object. So you can see that we have the donate function, we have a constructor, we have a withdraw, we have a balance function. So yeah, this is just a JSON object that we need to have here, the ABI. And then the address is the address of our contract that we deploy on Lisk. So I can come to Lisk, and then you will see the address that we have here. So let me know, guys, if you got lost here, but basically we just need to add the ABI that I got from Remix. We don't really even know to dive into what an ABI is, just to know that we need the ABI to be able to interact with the contract. And then we need the address. That is the address of the contract that we deploy on Lisk. So we need to deploy the contract to be able to interact with the contract in the front end. Otherwise, it will not work. And then I will just put here address. So let me know if you guys have any question with this step. I will stop in every step. So in this step of the contract initialization, is everything clear? Okay. More reactions? Rufai, I saw you. What about the other ones? Okay, perfect. So yeah, as you can see, I've written only these lines of code in this React application. And then to make this fun now, what we can do is interact with the contract. And then you will see like, wow, this is way easier than I expected. So remember that we have two types of functions in Solidity, reading functions and writing functions. To interact with reading functions is really easy. So I will just create a new, so get balance, a new function, and this get balance function will interact with the smart contract to fetch the balance. So let me just put this button here. When we click in the balance, button, we are going to fetch the balance of the contract. Okay, do you guys, yeah, you say that you were familiar with React, so you know what we are doing here. Just to kind of show you. Actually, let me add a use effect here. Balance. And then let's put something here. Okay, if we come to the React app, what I did wrong here. I don't know what I did wrong. React. I'm in a new computer and I always have issues with this undefined. Why is undefined here? Let's just leave it like that. That's simple. If the use effect is not working, then I will just, okay, never mind. Okay, perfect. That's great to know, Rufai. I don't know what's the error, but I will just do that in the console. So it's just easier. Okay, so I just want to have here console fetching balance, and let's see if it works at least. So you can see our three buttons. If I click in balance, okay, it's printing fetching balance. Okay, so we are good. So to fetch the balance, what we need to do is to use this contract instance. So we need to type my contract dot methods dot balance dot call. This dot balance is coming from the smart contract that we have. Remember that we call the function balance. But then if let's say that this function is called fetch balance, for example, then we will need to type in the React app fetch balance. So this function needs to have the same name of the smart contract function. So yeah, I call it balance. So we also call it balance too. So that's why here, when you go to the list explorer, you can just double check what is the name of the function that is here, balance. Okay, so we have balance.call. We are going to store this in a variable balance and wait, and then current balance is, and then the balance. So basically, I just wrote this line of code using the contract instance, my contract dot methods dot balance dot call. Let's say that we have more functions. So you can literally copy paste the same, but then change the name here. Function name 1, function name 2, and so on, right? So the only thing that you need to update is this keyword after the methods, but everything is the same. My contract dot methods dot function name dot call. This is with reading functions. Don't forget that. Only with reading functions. With writing functions, we need to type something else. Instead of call, we need to type .send. But I'm going to cover that later. But yeah, any question with this guy so far? Since you are familiar with React, yeah, seems like maybe it's easier. Is that clear? Okay. Great. Now, if I click in balance, you can see that fetching balance and then say current balance is 0. That means that we are interacting with the contract, right? Let me just put something here. Something that I want to show you so you are able to understand that we are interacting with the blockchain is right now in my MetaMask, I have the list Sepolia testnet. But if I change to Ethereum, for example, and then I try to fetch the balance, I'm getting an error. Because what we are trying to do is calling this a smart contract, like this address, in the Ethereum mainnet, but that contract doesn't exist in mainnet, in Ethereum mainnet. That contract only exists in Lisk. So that's why we need to make sure that we are connected to Lisk. But if you're a developer, you need to make sure that you can put like an alert to the user saying like, hey, please make sure that you are connected to Lisk because our contract is deployed on Lisk. Otherwise, it will not work. So if I come back to Lisk, I click in balance, you can see that now it's working. Is that declaration statement clear? You need to be connected in the network that you deploy the contract. Okay. So now we can implement the other two functions, that is donate and withdraw. So let's put them here in writing functions. Donate, withdraw. Let's just connect the buttons too. Withdraw. Then I will just put these consoles to make sure that it's kind of working. Withdrawing and donating. Okay, so far the functions are empty. And let's start implementing the donation. So before we interact with the writing functions, remember that to interact with writing functions, we need to have funds. We need to have a wallet that is connected, right? So the question is here, how we can ask the user to connect the wallet. So we can ask the user to connect the wallet by using this method that is called request accounts. So we need to type, remember that we are using Web3.js. So in this case, I put Web3 FiTech. So we need to type Web3 FiTech.eth.request accounts. And basically this line of code will ask the user, hey user, please connect your account. So I'm going to show you that right now. Sing function, connect wallet. And then cons wallet. So I'm going to create a new button that says connect wallet. And then this connect wallet will ask the user to connect the wallet. And then let's say, let's put here some console. Connecting. And then wallet connected. This web3.eth.request accounts method will return an array with the addresses of that the user connected. So if I call this connect wallet function, let me just disconnect this first. Okay, so if I click in connect wallet, you can see that MetaMask is popping up here, asking me to connect my accounts. If I connect both accounts, and then I click in connect, you can see the wallet connected, and then it's sending the array with the two wallets that I connected. Then if I disconnect my accounts, and then I try to connect again, and then I only choose one, this one, we will say wallet connected, and then we have the wallet here. So now, guys, you can see that only by using this line of code, 69, web3.eth.request accounts, we are asking the user, hey, user, please connect your account. Please connect your wallet. Simple. When I learned this line of code, it was like, wow, okay, this was like a mind opener a little bit for me. But then what we are going to do is return wallet in the slot 0. So we just return the first wallet that the user connected. I think it's clear. If you guys have any question, please raise your hand or something so I can come back to the meeting. Okay, so what we are going to do is for the donate function, just sit here. We need to type my contract dot methods dot donate, because remember that this is the method that we are calling, and then instead of dot call, we need to type dot send, because now we are sending a transaction to the blockchain. We are interacting with writing functions, and then this dot send will receive two parameters, like an object with two parameters, a from and value. So the from is the address that is sending the transaction, right? So I will call this message.sender. Let's say const message.send, message sender, connect wallet. So what I'm doing here is just using this function to tell me what is the wallet that the user connected, right? Because if I call that function, even after the user is connected, you can see that it will always show me the wallet that the user connected. And we always need to specify what is the address that the user is using to send a transaction. So that's why I type this, my contract.methods.donate.send message sender and value. This value is the value that we are donating. Like the right way of doing this is putting up a React form and then asking the user how much ETH you wanna send. But in this case, I will just hard code 1 ETH. So let's put wait to ETH. And then if I put 1 Ether, this is the value. Perfect. So what I'm doing here is 1 Ether in this case. what I'm doing is interacting with the contract. This wallet is sending this value. In this case, it will be 1 ETH. This will return something that is called transaction receipt, in case that you want to just check it, and then we can print in the console the transaction receipt. Okay, and then what I'm going to do is just to try to donate. And we're getting an error. Valid sender. Why we're getting an invalid sender? Let's see. Let's see what we are getting from here. Oh, okay. I missed this await here. Yeah, we need to type this await so the user first connect the wallet properly, and then it returns this wallet that is connected. So if I click in donate, you can see that MetaMask is popping up, and it's telling me that I'm sending 1 ETH. And then I'm interacting with this method that is called donate. And the fee for this is 0.30 cents in testnet. So this is free. And if I click in confirm, the balance right now is 0. You can see that I just click here. But now that the transaction went through, I fetch the balance again. Let me just refresh. And let's just wait a little bit. What's happening now is that supposedly the balance should be 1 ETH. Okay, so we can see that the current balance is 1 ETH now, because we just donated 1 ETH. So if I click in donate again, I will donate 1 more ETH. Okay, transaction receipt is here. You always see the transaction receipt with some data of the transaction in case that you want to check. Then if I refresh, let's see, it's not updated yet, but the balance should be 2 ETH, right? Okay, so now the current balance is 2 ETH, because now we just donated 1 more ETH. So do you guys have any question with this so far? We just donated, and then we are just fetching the current balance of the contract. Okay, seems good. Perfect. Thank you, Jetro. So the other thing that I will do is to implement the withdraw function. So I will be able to withdraw the funds, right? So I will just use the same message.sender here, just to see who is sending the transaction. Const transaction receipt. Await, and then the contract instance, my contract dot methods dot withdraw, because that's the function that we are using, dot send. Then remember that in dot send we have the from, which is the message sender, and then in this case we don't have value because the function withdraw doesn't receive any value. It's only the donate that receives the value of the donations, but this one is only withdrawing the funds. Then console log, transaction receipt. Okay, so what I'm going to do just to show you this is, in my wallet right now, you see that I have 48 ETH. This is the testnet ETH, right? If I donate more, I would have 47. Let's see if it allows me to donate more. Okay, so I'm donating a lot of ETH. So I had 47, but now I have 44, right? Because I donated like 6 ETH in total. If I check the balance of the contract, we can see that the total balance of the contract is 6 ETH. And we can even come here to the list block explorer, and you can see that the balance of this contract is 6 ETH, right? But now I want to withdraw the funds. So if everything works well, my balance will jump from 44 to 50 ETH, right? If we implemented the withdraw function properly. So I click in withdraw. It's saying you are calling the withdraw function. Confirm. Transaction receipt here, so it worked well. And then if I check the balance, not updated yet. And then here, you can see that in the block explorer, the balance is already showing 0 ETH again. And now if I come to my MetaMask, I have 50 ETH again, because now I withdraw the balance from the contract to my wallet, right? To this Vault wallet, which is, I'm the owner of the contract. And now if I click in balance again, current balance is 0. So basically, this is how you guys can interact with the smart contracts. It will be, maybe I can also get another, I will do another example so you are able to understand this. But just remember, smart contracts are only doing writing functions and reading functions. If you are able to understand with which function you're interacting with, it will be really easy to create a front end for this, right? So as you can see, I implemented here every function. Let me actually do something even better. So I will put this on GitHub, but then I will put the contract. So just for you guys to have the contract there too. Okay, here. Then let me just put this on my GitHub. My tech workshop. Okay, so if I check this, all the codes should be here. Here is the contract, here is the React app and everything. But then to make even something better, something that I was doing when I was learning all these things is when you create a DApp, you don't want to have this in a local host, right? Like you don't want to send to a recruiter, like, hey recruiter, please check, open my GitHub code and run this locally. Like no one will do that. So what I'm going to do now is show you Flick. Flick is a app, a platform that I used 2 years ago and still there, that allows you to put your React application into a decentralized storage, so your website is publicly available. So if I come here, you need to create an account. You click in deploy your site. Then you need to connect your GitHub. And then you need to give permissions to the repo where you have the code. So in this case, let me just check this. What is it? Okay, so I just need to give permissions to this repo. This what I'm doing right now is just to deploy the front end to a decentralized storage in case that you want to do that too. We just look for the repo here. Deploy site. And then what will happen is that in a couple of minutes, I will be able to send you an URL, and then you will see this app. That you will be able to interact with this app from your computer. And that's way better. Like that's what I was doing when I was getting into Web3, building a DApp, putting this DApp on GitHub. Then from GitHub, I deployed on Flick. and then I was sharing the URL with everyone. Let's just wait a couple of minutes. I don't know if you guys have any questions so far, but yeah, we're kind of, this is everything that I really wanted to show you, because if you are able to follow this workshop, you will be able to create any React application to interact with any smart contract. So it's just about maybe more repetition. And I will be also able, if you guys have any specific questions or anything that you want me to do specifically in January, I will be able to do it again. I'm really happy to help you get into Web3, to help you understanding about Web3 integration. But the main topic of today was, we wrote the smart contract, we wrote the React application, and then we integrated both using Web3.js. But let's have this here. It's just taking a while. Let me just close the app. I will share this repo with you. I will send you this, George. Or maybe, I don't know if you're able to get it from here. So you can share this later. Perfect, thank you. What I just want is to deploy this. Let's see. Yeah, this always takes like a couple of minutes. But then here we will have the URL, and you will be able to interact with this React app. Of course, some things that you can improve. First is the front end, like the design itself. This looks really ugly. So make sure to do something nicer, to add a background, some colors or whatever. Second thing is, don't show this in the console. Like, a recruiter will never know how to open a console. Like, that's not the point. You need to have that here. Like, every time that you connect the wallet, you want to show the wallet that is connected in the front end. So you can use, I think it was use effect. I forgot, but yeah, I think it was use effect to show everything here in the front end. This is working now. So as you can see, if I visit this millions bit noisy on Flick, my React application is here. And this is not my local host anymore. So if I share this to you, amazing, Jetro. Thanks for that feedback. So if you visit this link, this is the app that we just make right now, right? And then you will be able to connect your wallet, to interact with the wallet, donate, withdraw, etc., etc. But remember that everything is showing in the console. But yeah, basically that's what you do for the whole process. We wrote the smart contract, we make the React app, we integrated the blockchain with the React app, and then we deploy the React app into a decentralized storage like Flick, and then this will stay here, that we can share with our friends on LinkedIn or with the recruiters or whatever. You can put this on your CV, so the recruiters go there and see what you built. That's what I was doing before. So yeah, basically in terms of the technical workshop, I will say that that's everything. As I say, guys, I'm really excited to come back to help you with more things. If you have any more questions too, feel free to tag, to ask me or whatever. But yeah, Chuku, tell me.
Okay, so on the connect wallet functions, kind of, can we make it so simple? Kind of, can we put it inside the donate function so that the user don't have to kind of perform two actions before donating? Let's say the user don't have to connect the wallet. Just when the person click on the donate button, it will automatically first pop up the connect wallet. Then after the connect wallet, it will now suggest for the amount of value to donate.
Yeah, what I was doing is just to make it easier. The only thing that I was using the Connect wallet was to get the address that is connected, right? Because I was returning the address that is connected. But you don't need to call the Connect wallet before they donate. Yeah, that's accurate. You don't need to do the double call. If you already have the from, that is the message sender, like the address, is okay. But you don't need to do the double function. I don't know if that answered the question, if I got it right. Perfect. Wait, let me actually take a screenshot here. I will take a screenshot. I don't know, guys, if any of you want to turn on the camera, it will be fine to take a screenshot to send it to the Fight Tech group. Then George can make his Twitter magic later. Oh, nice. Nice, George. You're here. Okay, so okay, DK. I don't think anyone will turn on the camera. I noticed that no one really likes the camera. Everyone is shy. But that's okay. Okay, DK is here. So let's just take a screenshot. Let me just, okay, I will count to 3. So Smile, George, Rufai, DK. That's great. You guys are here. Okay, let me just ping you too. Okay, oh, okay. The crowd is getting active now. Oche, Martin, David. Wow. Okay, this looks good. Okay, I'm taking a screenshot in a few seconds. So, okay, so smile. 1, 2, 3. Okay, that looks good. Okay, that's perfect. So yeah, I'm here open to any questions, even if they're not technical questions. Just feel free to. Can I put it? Yeah. Okay, David, put the shirt, and then we take it again. Yeah, so you don't look like naked. But the thing is, everyone turn off the camera. Hopefully, they will get it again. But yeah, let us know. I'm just sending you this photo. Okay. Okay, let's retake the photo. Okay, that's great. Okay, so I will take it again. Smile. Hey, George, where's your smile? Okay, 1, 2, 3. Okay, perfect. I send you. So yeah, feel free to do that or whatever you want to do. Send that to Faith. So yeah, guys, if you don't have any questions, I think we are kind of done for the day. If you have questions, feel free to ask me whatever you want about anything. If I have the answer, I'm really happy to answer. Yeah, DK. Oh, where are you
Okay,
sending
I
that?
wanted to ask, like, is that like a platform where you feel it's like a safe place for us to go and like practice more, learn more about Web3, like a link or something like that? Or do you have like a personal page where you give like mentorship or coaching advice to people trying to understand and get more into Web3?
So I'm going to share 2 things. The first thing is my favorite YouTuber to learn about Solidity, which is this one. Oh yeah, let me put my X. Wait, I'm going to share some resources with George, and then he will share that in the group. That will be better. So let me just send that to him. Solidity YouTuber, Web3 docs. And then for my Twitter, yeah, it would be nice if you guys follow me. To appreciate the follow from you. Yeah, so DK, to answer your question, I just share some resources with George. We will share that in the community later. And yes, okay, too cool. Any more question, guys? Yeah, they can.
Okay, sorry to interrupt again. I'm not quite acquainted with Josh, so I don't know how I'll be able to like get get acquainted with the community and so on. Because I actually came in through an invite from a friend, and the friend
Uh,
is not really correctly active, so I don't know.
okay, so let me just send the links here. That's- Mm, So that one is my favorite Solidity kind of YouTuber. You will learn a lot from that guy. These are the Web3.js documentation. And then, of course, this is really good Web3 full course. If you finish this course, the one that I'm sending the links, the one that I send the link, you will be able to do a lot of things if you follow everything there. And it's really easy to follow. So yeah, all the resources are there. Yeah, I think that's, oh yeah, and then you can join the Bytech community, WhatsApp community there. Yeah, George.
Yeah, Santiago. I this tend also invited to the league's office hours tomorrow.
Oh, okay, yeah, that's true. So guys, here is a Luma event, like a online meeting that I'm hosting tomorrow. This Luma event is for Lisp. My main priority are developers and helping people to get started in Web3 or supporting developers if they already have ideas to kind of go to market or even to get funding or whatever, depending on the stage that you are. So tomorrow I'm hosting these 2 hour office hours to do whatever you want. Like you can come and ask questions, you can come and share ideas, you can come and share initiatives of what you guys think that we should do to support developers. So for example, just to give you some little spoilers here, we are having builders hubs in Africa to have a safe space for developers to come here and work and just develop and focus on what they are doing. So right now we have one in Kenya, and we are planning to have one in Nigeria too. So I don't know where yet. It may be in Enugu, Abuja. I don't think in Lagos, but I think in Enugu or Abuja. And yeah, basically having a house with beds, with good Wi-Fi, with everything, so everyone is able to come here and have a safe space, kind of to say it like that. So yeah, if you think that you can come to these office hours, ask questions, share initiatives, give feedback, whatever, that would be really useful because that's the only way that I'm able to gather feedback, hearing things from you, right? So so yeah, I will also share that in the PyTech WhatsApp community. It's here. And yeah, and then I'm really happy to come back to you guys whenever you need something. What time is that? That is at let me check Nigeria time. Right now is 1 p.m. 2, 3 at 4 p.m. Nigeria time tomorrow. From 4 to 6 tomorrow. So yeah, if you guys want to join, feel free to join. Feel free to also follow me on Twitter or text me, send me messages on Twitter. I'm really happy to help. And yeah, hopefully I will see you also, some of you guys in person in 2025. But I'm planning some trips to Africa again. In case that you didn't know, let me introduce myself a little bit now. So I like to call myself as the first DevRel, like developer relations, who did a Web3 Africa tour, because I was in Ghana, Kenya, Nigeria and Uganda, teaching about all these things of making the first DApp, writing your first smart contract. That's why I got these bracelets from Nigeria, Ghana, Colombia, Uganda, and Kenya. I always get one in every country that I go in Africa. So I'm really passionate about Africa. That's why I'm here today. So yeah, hopefully we'll see you in person in Africa too. So yeah, if you don't guys have any question, hopefully I will see you tomorrow in the office hours, or I will see you in January, or I will see you in person, or whatever. But hopefully we keep in touch.
All right.
Excellent.
Thank you so much, Santiago.
Thank you guys. I will leave now. If you need something, send DM.
All right. And thank you everyone for joining in. So
Bye-bye.
bye and have bye.
Hello, sir. I don't know.
He has left the code.
Okay, okay. Now, okay, I wanted to ask like that. Is there any class next week again, or this was the final class?
Okay, in regards to that, this is the final class for the bootcamp.
Okay.
So official classes for the bootcamp has, well, the reactions. Official classes for the bootcamp has come to an end today, but hopefully we would still be having a project to work on as during this December till January. The sub-mentors will be getting us some kind of project we can work on, and we're also planning for probably an hackathon next year. So for all the students that participated in the bootcamp would be having a hackathon. So in case of any support you might need in terms of development or in terms of reforms, you can feel free to also reach out to any of the sub-mentors or drop me. So there will not be class this week, next week, no more bootcamp classes again. So we might be having some special sections. So just keep on thinking, and every update will be dropped here. So thank you very much, everyone. I don't know if there's any other question. Okay. So I assume there's no more question regarding it. So I'll call it a wrap here. Okay, all right. Okay, you can go on. I'll share. Good one.
We can access the recordings are on YouTube, right?
Yes, the whole recordings from the first day down till today will be. Oh, yeah.
Okay.
YouTube.
All right. You can just drop the link.
All right. I will do that. So just always check the Discord channel. That's where there's a channel for recordings. So every link of the recordings are there. So the recording for today will also be dropped. That will be later on. So we should expect to also get that. All right. And okay, the special section, Santiago promised me personally that we'll still be having some sections in January. So let's also anticipate that regarding Web3 integration. So is there any other question? All right. Yeah, thank you very much, everyone. Thank you for joining in. Okay, attendance. Whoa, I think we dropped attendance today. All right, don't worry, I will take the attendance from the. And I don't have any of the attendance to recall. Let me just take a screenshot. All right, so I guess that would be all. So we drive back end and do it. Okay, back end. Okay, we still have more bootcamp coming up next year. So regarding having the back end bootcamp, we look into that and hopefully we might do something on that. But just note that we have the major bootcamp we're having early, that's first quarter of next year. We have that on data analysis and specifically. So more or less like what we've started off today, we'll be having a full-blown Web3 bootcamp. We're focusing more on solidity and Cairo. Yeah. So especially Cairo, Cairo is in trend of Stacknet and so on. So any other question? I wanted to really answer every question. I think we are good to go. So any other announcements will be passed across on the announcement channel. Please let's be active. And I've been seeing some of our posts on Twitter. Let's keep on doing that. So helps the community and also put us out there and show the world what we are really doing right there. So since there's any other thing, we'll call it a wrap at this point. So thank you very much, everyone. Thank you for joining me and have a very nice day ahead.